In this video, we're going over number properties. In the last video, we went over these basic number properties. Be sure to check it out if you missed it. In this video, we're going to go over the properties of negative numbers. Our first rule here is -1 times a is equal to negative a. So as a numeric example, let's think of -1 times 3, and we would get -3. Now for an algebraic example, we might have something like -1 times x, we get -x. This is also useful to think of in reverse, for if we have something like -xy, we know that it's the equivalent of -1 times xy. Our next rule is negative times -a is equal to a. Now the key with this rule is to recognize that when we have a lone negative, it is the equivalent of -1. So this is -1 times -a is equal to a. So this lone negative needs to be thought of as -1. Then we have two negative values being multiplied, and we end up with a positive value. So something like negative times -12, we will have -1 times -12. That lone negative is like a -1. Thus, we've got a negative times a negative giving us a positive value. Our next rule is -a times b is equal to -ab. Let's dissect this for a moment. As we have -a times b, let's recognize that this -a is really the equivalent of -1 times a, as we talked about in the first rule. So we have -1 times a times b. So really, this -1 right here can be written as a lone negative, because a lone negative is implied to be -1 ab. There you go. As a numeric example, we might have something like -3 times 2. So we can think of it as -3 times 2 and get -6. Our next rule is a times -b is equal to -ab. Examining this rule, we know that a times -b is really equal to a times -1 times b. That -b is really the same as -1 times b. Now from the commutative rule that we went over in our previous video, we know that order of multiplication doesn't matter, so we can rearrange this in any sequence. We now can have -1 times ab. We can treat this -1 as a lone negative instead of writing -1, and so then we get -ab. Next, we have this rule where we have negative times, in brackets, a plus b is equal to -a minus b. Now, once again, let's think of this lone negative as -1. So this is the equivalent of saying -1 times a plus b. From here, we use the distributive rule, also talked about in our previous video. And so we multiply -1 times a, we get -a, plus -1 times b, we get -b. This then becomes -a, and adding a negative value is the same as subtracting. So -a minus b. For a numeric example, let's think of -4 plus 6. We know that inside the brackets is going to be 10, so then we'll end up with -10. But what we can do instead, we can start to think of this as -4 minus 6. So we have -4 minus 6, and this also gives us -10. Now for our final rule here, we have negative times, in the brackets, a minus b is equal to -a plus b, or b minus a. Once again, let's think of that lone negative term as -1 times a minus b. So then we distribute that negative to each term within those brackets, and we get -a minus -b. Now we're subtracting a -b, which really is the same as adding a positive b. So we get -a plus b. Minus a minus gives us a positive. So we get -a plus b, as written here, This can be rearranged to be b minus a due to the commutative rule of addition where order does not matter. And there you go. Those are the properties of negative numbers.